This is practice problem number 3 from lesson 14, Solving More Systems, and unit 4, Linear Equations and Linear Systems. And this is the long version of the solution. So what I did is at the end, I created a word problem that contextualizes the solution. So in this problem, you're given an equation, y equals a negative 1 5/10 x plus 3. And you're supposed to find a second equation over here that when combined with this first equation forms a system with only a single solution, one solution. So when you see that, you have to think of the slope. So if the slope is different between this equation and the equation over here, they will have a single solution. The graphs of those two equations will intersect at one place, giving one solution. If the slopes are equal and they have different y-intercepts, there will be zero solutions in the system. If they have the same slope, the same y-intercept, then they will be the same equations, and it will have an infinite number of solutions. Those graphs will fall right on top of each other. So the slope has to be different to have a single solution. Now this equation is written in the slope-intercept form, so that means that the coefficient of x is the slope. It's a negative 1 5/10. So this is y equals mx, so m is the slope, plus b. b is the y-intercept. So over here, if each of these are rewritten in the y-intercept or the slope-intercept form, then you just have to look at the coefficient of x. If it matches, then the slopes are equal and the graphs are either parallel or identical. If the coefficient is different, then the slopes are different and those graphs will have a single solution. All right, so y equals a negative 1 5/10 x, so same slope, but different y-intercept. So this system would have no solutions. Those graphs would be parallel. Likewise, these graphs, this graph between b and this equation, in this case, actually, the y-intercept is 0. So this passes through the origin, and it has the same slope. So parallel graphs, no solutions. These two equations are identical. If you add a negative 3x to this equation, then you're going to get 2y equals 6 plus a negative 3x. And this equation then matches this equation. And both of them, they're identical equations. They have a slope of a negative 3/2, which is the same as a negative 1 5/10. And they have the same y-intercepts. So these three equations, d, c, and the beginning equation are all equal. So they would have, in a system of equations, they would have an infinite number of solutions. Their graphs would fall right on top of each other. That leaves just e. E has a different slope, so it's going to have just a single solution when forming a system of equations with this first equation. So this slope is a negative 2. This slope is a negative 1 5/10. Different slopes, a single solution. Interestingly, that solution actually is 3 because they have the same y-intercept, which is at 3. So E is the answer. It's useful to look at this problem in context. So here's a story, and I underlined some of the important points in this story. So Juan and Andy are siblings. Juan walks a bit faster than his sister Annie. So he walks at a rate of 2 miles per hour. Annie walks a little bit slower at 1.5 miles per hour. And remember that 1 5/10 is the same as 1.5. It's the same as 3/2 miles per hour. They live 3 miles from the park. So on the graph, the y-axis is miles from the park. And there's that 3 right there. So here's their home, 3 miles from the park. If both Juan and Andy start at the same time from their home, how long will it take each to reach the park? That's when y equals 0. So they're walking in this direction. This is time. So they're walking, and they're walking towards the park. So miles from the park is getting less and less and less over time. Now they actually don't have to leave at the same time to figure out how long it will take each to reach the park. But if I rewrote the story to say which sibling arrives first at the park and how long do they have to wait for the other sibling to get to the park, then they do have to leave at the same time. So here are the graphs. So one equation is y equals a negative 1 5/10 x plus 3. So they're starting 3 miles from the park, and this person, which turns out to be Annie. She's walking at 1.5 miles per hour, and she's getting closer to the park. So we'll talk about why this is negative in just a moment. Juan is walking 2 miles per hour. He starts 3 miles from the park, and he's walking 2 miles per hour towards the park. So this is Juan's equation. So this is Annie, and so she takes 2 hours to reach the park. So you can get that from the graph. And this is Juan, 1.5 hours to reach the park. So let's go up here to the slope. So Annie has a slope of negative 1.5 miles per hour. So in 1 hour, she walks a negative 1.5 miles. That's this along this axis right here. Another hour, she walks another 1.5 miles. So she's at the park because 2 times 1.5 is equal to that 3 miles. Juan walks 2 miles in 1 hour. So in 1 hour, he walks 2 miles, but that's a negative 2 miles because he's walking towards the park. In another hour, he walks another 2 miles. So now he's past the park. He's actually 1 mile farther past the park. So it only takes him 1.5 hours to reach the park. So that's right here. So let's look at the algebra. So Annie is y equals a negative 1 5/10 x plus 3. So notice it's a negative 1 5/10 because as she walks, she's removing distance away from the park. She's getting closer to the park. So for each hour, she gets 1.5 miles closer to the park. So that has to get subtracted from 3, or adding a negative 1 5/10 for each hour. So y is 0. 0 is when they are at the park, or when she is at the park. So when 0 is equal to a negative 3.5 times x, remember 1 5/10 is the same as negative 3/2 plus 3. So now it's easier. I wrote this as a fraction because it's easier for me to see that to get rid of this coefficient, all I have to do is multiply by a negative 2/3. So it's the multiplicative inverse, or the reciprocal, of a negative 3/2 is a negative 2/3. But I'm going to move it over to this side first. So this is becomes 3/2 x equals 3. So now it's easier to see. So to get rid of this coefficient, multiply it by 2/3. So 2/3 times 3/2, this all equals 1. So that makes this coefficient 1. So now you have just a single x equals, and these 3's will cancel. So the 2's cancel, the 3's cancel. This becomes just x, or 1x. And over here, these 3's cancel. So 2/3 of 3 does in fact equal 2. So it takes Annie 2 hours to reach the park. So when y is 0, x is 2. So when x is 2, y is 0. For Juan, again, it's a negative 2, because again, he's removing distance away from the park as he walks. So for each hour, he removes 2 miles from this 3 miles where his home is. So y is 0. He's at the park when y is 0. So how long does it take for him to get there? And that's x. So a negative 2x plus 3. So move the 2x over to the left side by adding 2x to both sides. So 2x equals 3, multiplied by the multiplicative inverse of 2, which is the reciprocal of 2, 1/2. Some of you might say divide by 2. That's okay also. I like looking at the multiplicative inverse. So 1/2 of 2 is 1. So this becomes 1x, or just a single x, and that's equal to 1/2 times 3, which is 3/2 hours, 1 1/2 hours, or 1 5/10 hours. These 2's cancel out. And so notice once again that the solution is 0, 3. So when y is equal to 3, that's when they are home. They are in the same spot at the same time. So that's when these two graphs intersect. Take a look at where Annie is when Juan has reached the park. So here's Juan. He has traveled for 1.5 hours. Here's 1 hour, another half hour, and he's traveled the 3 miles to reach the park. Annie is right here after 1.5 hours. So she has traveled 1 mile, 2 miles, and a little bit more, and that is 1/4 of a mile more, and she has 3/4 of a mile to go. So what are the calculations to determine her position? 3/4 of a mile from the park and she's traveled 2 1/4 miles. So zooming in just a bit, there are a couple of ways to show the time for Annie's travels. I'm going to use the arrow diagram. This is 1 hour. Basically up here it's 4 grid lines. 1, 2, 3, 4. 1, 2, 3, 4. So this is 1 hour on this scale. And also I showed her time as a clock. So if you go around for 1 hour, that's also 60 minutes. So 10 minutes, 20, 30, it's a half hour, 40 minutes, 50 minutes, and 60 minutes. So in this hour, so going around this amount of time, 1 hour, she has traveled 3/2 miles. And that makes sense. So 1 hour, she's traveled 3/2 miles. It's right here. So this is 1 mile, a half a mile, so that's 3/2 miles. So Annie is going to travel 1 more half of an hour. So she's right here at 1 1/2 hours. And remember, it takes her 2 hours to get to the park. So that's 2 grid lines. And if we go around just to the 30 minutes, she has traveled half of 3/2. So how much is half of 3/2? So 1/2 hour times 3/2 miles per hour. Well, 1/2 times 3/2 is 3/4. So I'm going to zoom in on this a little bit so we can see it a little bit easier. So again, here is Annie's travels, the 3/2 miles over 1 hour. So he travels 1 hour, 1 hour all the way around. Annie travels 3/2 miles. This is 1 mile. This is a half mile. Now I know I'm going to have to calculate half of 3/2. So I'm going to change this next 3/2 miles to 6/4. So 3 times 2 is 6, and 2 times 2 is 4. So this is the 3/2 miles that we just looked at. And so now Annie's going to travel another half an hour, and that's going to equal half of 3/2. I just showed you that that is equal to 3/4. So if I take the 3/2 right here, this would be the second hour. And if I rewrite that as fourths, so 1/2 is 2/4, another half of a mile is another 2/4, another half is another 2/4. So this is the 6/4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Well, half of 6 is 3. So this is the 3/4 further that she travels. So zoom back out just a little bit. So this is the 1 hour and 3/2 miles. And this is the second half hour and half of 3/2 miles, which is 3/4. So 3/2 miles per hour is what Annie's traveling at. So 1/2 of that in 1/2 of an hour. So 1/2 of 3/2 equals 3/4 miles in 1/2 hour. All right, so Annie has traveled 3/2 miles plus 3/4 miles. So 3/2 miles plus 3/4 of a mile. Add those together. Here are the 6/4 again. So 2 times 3 is 6. 2 times 2 is 4. Changing 3/2 to 6/4 and adding that to 3/4. Remember, you have to have a common denominator here to add them together. That equals 9 total force miles. Well, 8/4 is 2. So that's 2 1/4 miles that she's traveled. So this up here is 1 mile, 2 miles, and 1/4 of a mile. And she has 3/4 of a mile more to reach the park 3 miles away. And that makes sense. She has to travel another 1/2 hour. And we just calculated that 1/2 of an hour is equal to 3/4 miles. So 3/4 miles farther to travel in that 1/2 hour. I also want to take another look at figuring out which of these 5 equations forms a system with this equation that has only one solution. I want to use the standard form of the equations to do that. So remember, the slope-intercept form is y equals mx plus b. And in this case, m is the slope, and so the slope is a negative 1 5/10. So, but using the standard form, how do you look at the standard form and calculate the slope from the standard form? So this is the standard form, ax plus by equals c. So 3x plus 2y equals 6. So I just added a positive 3x to both sides. So this becomes 3x plus 2y equals 6. And the slope is the opposite of a divided by b. And you can start to see how that happens, because to get y by itself, you're going to subtract this term from both sides. So you're going to get a negative ax. So that's going to be a negative a in the position of m, the slope, and you're going to divide through by this b. So it's going to be a negative a divided by b. And so the slope for c is a negative 3. The opposite of a is negative 3 divided by 2. So you divide through by that 2, and you get an answer of a negative 1 5/10. Same slope as up here. The second equation, d, is the same equation. So if I just rearrange these terms, so 3x plus 2y equals 6, it is the exact same equation as above. So once again, the slope is the opposite of a divided by b, because you're going to divide through by that 2. The opposite of a divided by b is a negative 3 divided by 2 equals a negative 1 5/10. So all three of these equations have exactly the same slope, a negative 1 5/10 or a negative 3/2, and they all have the same y-intercept. The y-intercept in the standard form is c divided by b, because remember, you're going to divide through by that 2. So 6 divided by 2 is 3. So the y-intercept is 3, y-intercept is 3, and up here the y-intercept is 3. So these three equations, in any combination to make a system of equations, has an infinite number of solutions. So each graph lies right on top of each other, so they have the same slope and the same y-intercept. And a and b are in the slope-intercept form, so this is negative 1 5/10. So no solution. These lines are parallel. This line with this line with this line. They're all parallel. They have a slope of a negative 1 5/10, but different y-intercepts. Y-intercept is 0, y-intercept of 6, and a y-intercept of 3. So parallel lines all have the same slope, but different y-intercepts. And again, that leaves the only answer that has a single solution as E. Different slope, a single solution. Different slope of negative 2, a single solution when forming a system of equations with this equation up here.